In this lesson, we're going to start talking about factoring polynomials. Now, to factor a polynomial means to find out what was multiplied together to give you the polynomial. Well, before we work with polynomials, let's review factoring with whole numbers. If you have the number 6 and I ask you to factor it, you would realize that it was 2 times 3. Those are the prime factors of 6. If you had the number, say, 12, then as you factored it, you might say, well, it's 2 times 6, but 6 is 2 times 3. So the prime factors of 6 are 2 times 3. The prime factors of 12 are 2 times 2 times 3. Prime factors. Our entire study of factoring polynomials will be geared toward trying to find the prime factors of polynomials. When do you use factors? Well, one setting you use is reducing fractions, multiplying fractions, dividing fractions, and so on. Let's suppose that I ask you to reduce 6 over 12. Now, you might do this a lot of ways, but one of the ways, the most fundamental way, is to write the numerator and the denominator as prime factors, divide out common factors, and that would leave you with a numerator of 1 and a denominator of 2. Now, we're going to be working with polynomials, not just numbers. So, factors are quantities that, if multiplied together, give you the number or the polynomial that you started with. So we have to be very comfortable with multiplication before we can unravel it with factoring. So let's review the distributive property. This is one form of multiplication. Whoops. All right, to review the distributive property, suppose you had 2 times 3x minus 5y. You would multiply the 2 times each of those, getting 6x minus 10y. If you had some variables, say you had 2x squared times 3x minus 5y, when you have like bases, you would get 6x to the 2 plus 1 or third power minus 10x squared y. All right, what we're going to be working with in this first lesson is abbreviated GCF, which stands for greatest common factor. And the greatest common factor is this quantity that was distributed. So our job is going to be to look at a polynomial, identify what both terms or all terms have in common, and then yank it back out, factor it out. So the lessons that we're going to be looking at will be looking at a polynomial and seeing if we can identify something in common and make sure it is the largest or the greatest factor that's in common in all of the terms, and we'll undo the distributive property. Let's take a look at some problems. The first one says factor out the greatest common factor, that's GCF, from the polynomial, and I'm given 2x plus 28. Well, is there a number that is a common factor between 2 and 28? The answer is yes. 2 is in common. What you're going to do, you don't have to write it down, but what you will be doing is dividing both of these terms by 2. 2 goes into 2x, x times, plus 2 goes into 28, 14 times. These no longer have a common factor. I now have 2 prime factors of this polynomial. Next one, I have x to the 8th plus 9x to the 7th. Now these don't have a common numerical factor, but they do have a common variable factor. What will go into both of those? And I think everybody sees an x. What power of x? Well, you can take no more than x to the 7th. In other words, you can only take the smallest variable power. So I will take x to the 7th out of both of those. By taking it out, I mean I'm going to divide it out. I use the quotient rule. That's going to give me x to the implied first power plus 9, and those divide out. So I have x to the 7th times x plus 9. So in problem number 1, I had a common factor, which was a 2, a number. And in number 2, I had a common factor, which was a variable, x to the 7th. Let's keep going. I have 3y to the 5th plus 5y to the 3rd. These two terms, this binomial, there's a common factor of 5. Both factors have y's. Remember, I have to take the smallest power, so it's 5y to the 3rd. I will divide 5y to the 3rd out of each of these terms. When I divide 5 into 30, I get 6. Y to the 5th over y to the 3rd, I subtract y to the 2nd, plus, now, some people would say these completely divide out. Yes, they do, but that leaves a 1 behind. Don't forget the 1. How could you check this? Distributive property. And without that 1, you could not rediscover that last term. All right, I have 14x to the 3rd minus 18x squared plus 4x. I look at all the terms and I see that I have what will go into 14, 18, and 4. The answer is no more than 2. X cubed, x squared, x. I can take no more than the lowest power. So 2x is my greatest common factor. Divide it into each of these. That's going to give me 7x squared minus 9 single x plus a 2. And those are my factors. I'm finding the greatest common factor and then dividing it out. Looking at a few more. This next one I have a to the 5th, b to the 7th, minus a to the 4th, b to the 3rd, plus a to the 3rd, b to the 8th, minus a to the 3rd, b to the 3rd. Common factor. All of these terms have a's. Remember, I can take no more than the lowest power. I have a 5, a 4, a 3, and a 3, so I can take no more than a to the 3rd. All of these factors have b's. I have b to the 7th, 3rd, 8th, 3rd. I can take no more than b to the 3rd. I'm going to divide a to the 3rd, b to the 3rd out of each of these. I have to write rather small. And I'm going to be using the quotient rule for exponents over and over. The first one, I'm going to get a to the 2nd, b to the 4th. I did 5 minus 3 and 7 minus 3. Minus, I'm going to have a single a, and the b to the 3rds divide out. Next, the a to the 3rds divide out, and I have plus b to the 5th. Minus, the a to the 3rds divide out, the b to the 3rds divide out, but when they divide out, although I don't always write it, it leaves little factors of 1 behind, so I have a 1. This will be a little bit challenging to type in because you're going to have to use that exponent tool so many times. Remember, if you're up in the exponent, you can either use tab or the right arrow key to get back out of it. All right, last one. I have negative 45 x to the 5th, y to the 4th, minus 36 x to the 6th, y to the 2nd. All right, this problem gives me the opportunity to tell you if the leading term, the first term of a polynomial is negative, the GCF must be negative also. Literally, even if it's nothing more than a -1. But in this one, what will go into 45 and 36? Well, 9 will. I have to factor out -9 because of this sign right here. This is the only sign that's causing me to factor out a -9 instead of a +9. All right, both terms have x's, so I'll need an x to the 5th, the low power. Both terms have y's, I'll need a y to the 2nd, low power. So I'm going to divide both of these by -9, x to the 5th, y to the 2nd, -9, x to the 5th, y to the 2nd. -45 divided by -9 is 5. The x's divide out, and I end up with y to the 2nd. Negative divided by negative is, whoa, I'm so sorry, is +4. X to the implied first, and the y's divide out. So I had that a little far away. Those are my factors. It would be counted wrong if you neglected the negative sign. This one is not the reason. It is the leading term. When the leading term is negative, the greatest common factor must be a negative common factor. Okay, work on a few of those.